रयत गीत प्ले होऊस तर तुम्ही थांबा.
मी थांबते की सर, कुठे जात नाही.
रयत गीताला जरा
नाही थांबा, मला YouTube चालू करायला लागतं सर.
अरे ही गेस्ट आहे,
ऍडमिट करून टाका एक सर. बघा ते झालं तुमचं सर. तुमच्या झूमला जावा पलीकडे.
कुठं?
पलीकडे
लॉन्च.
हा नाही खाली तुमचं झूम ती आली. हा आले बघा. तुमचं चालू द्या आता. YouTube चालू करू
सर. हे
सुरू झालं सर.
Hello, sir. Am I audible? Hello.
हाँ सर, you are audible, sir.
Yeah, fine. Shall I just try to share my screen and then check?
आलो एक मिनिट. करा.
Okay, you need to allow me to share my screen.
Okay, sir. Okay.
Yeah, just check before we start. Yeah. I hope my screen is visible to you.
Yes, sir.
Yeah. For time being, I can stop sharing.
So now participants are now joining.
Okay. No, I stopped sharing.
Okay, sir. Okay,
Yeah.
You can stop. झाली का जॉइन?
झालं?
हा
ती बसले सर त्याच्याकडे वाटतं.
अजून चालू नाही सर.
असं काय येतं सर?
ते बोलतात ना सर, त्यांचा आवाज. स्पीकर व्ह्यू करा, हे करा ना. व्ह्यू कुठला आहे? स्पीकर व्ह्यू सर. तुम्ही तुमच्या ह्याच्यावर गेला ही कंट्रोल, ठीक आहे. तुमच्या ह्याच्यावर सर होस्ट तुम्ही संपलाय, त्यांना गेल्यावर
हे काय
कर होस्ट ते.
हा आपण
तुमच्या ह्याच्यावर होत नाही. तुम्ही आला बरोबर.
कम्प्युटरचा आवाज येते व्यवस्थित?
येतो.
जे बोलल त्याचा आवाज तिथे चित्र दिसणार ते.
काढते की
सर आता
तर माझं YouTube आहे, मी घेऊनला नाही YouTube केलंय.
त्या पीसीला कोण बसणार आहे त्या नाही त्याचं लॉग इन कुठल्या ह्याच्यावरून करणार आहे कारण त्या नावाला पोस्ट करावं लागतं हा, म्हणजे त्या
डिपार्टमेंट ऑफ केमिस्ट्री
हे ना
हा हे केलं बरोबर हे डिपार्टमेंट ऑफ केमिस्ट्री
हे कोणतं आहे
बरोबर
नक्की.
नक्की
रिक्वेस्ट नाही
मेल थ्रू झालं म्हणून होते तुम्ही गोष्ट दाखवता
हो हो हा तुम्ही ते बघा सर
शेअर करा तात्पुरतं करा घ्या आधी शेअर करायला काय प्ले नंतर करायचं आपण
ऍडव्हान्स शेअरिंग मध्ये का
हा जावा की
इथे जाऊ
जावा की हा ओके ठीक आहे ओनली
नाही आता ऍक्च्युअली शेअर करताना
तिथूनच करायचं की सर शेअर स्क्रीन करा की बंद करायची
एक मिनिट. करू
करा की हा आता तुम्हाला काय पाहिजे
रहित गीत ते डेस्कटॉपला आहे
जावा इथं ही क्लिक करायची आलं का लक्षात
हम्म.
आणि कुठे डेस्कटॉप
डेस्कटॉप घ्यावं लागेल
ती ओपन करा ना सर कॅन्सल करा
हे cancel इथून करू
हा करा कॅन्सल आता हे करा
Minimize
minimize. हा आणि ते ओपनच करून टाका ओके करा सांगतो तुम्हाला आता आता त्या इथं जावा ह्याला
इथं
इथे पिवळ्याला
ह्याला
हा ओपन करा ती आणि कुठे
हा, इथं.
हा ओपन करा
डबल क्लिक
हा करा की आणि ते पॉज करा तर पुढे चालतं ते राहू दे ते इथं मागं घ्या फक्त ते हा आणि तुम्ही त्यावेळेस हे करणार
नाही ते तुम्ही मला करून द्या सर
हा हा मी आहे
हा.
तिथं हा मी ही मिनिमाइज करा आता हा आणि आता ते ह्याच्यात बंद करा ही बंद करा हा आता इथं जावा शेअरला परत आपल्याला ही करायचंय हा आलं का बघा बरं ते
आलं नाही का
हा आलं ना ओके करा आणि फर्स्ट का नको
आता नको.
नको ना ठीक आहे आणि त्यावेळी फक्त ते शेअर साऊंड फक्त म्हणायचं सर बघा
बरोबर आता काय करू
हा.
हे बंद करू का इथून नाही
हॅलो हा करा हॅलो
हम्म.
नाही बोला की इथं डिपार्टमेंटला
नाही बंद केलं तरी चालेल हम्म. सर इथून बंद करू का डायरेक्ट
बंद करा की सर काय प्रॉब्लेम परत शेअर करायचे आपल्याला शेअर आहे ना चला
एकदा I welcome you all in the national webinar on Introduction to Virtual Laboratory in Chemistry, organized by Department of Chemistry, Karmavir Bhaurav Patil Mahavidyalay, Pandharpur. The resource person of this webinar, Honorable Dr. R. Vijay Solomon, sir, He's a assistant professor in Madras Christian College, Chennai. He joined in this webinar. So on behalf of Department of Chemistry, Karmavir Bharao Patil Mahavidyalaya Pandharpur, I welcome you, sir. The chief guest of this webinar, Honorable Dr. R.B. Bhosle, sir, Director, School of Chemical Sciences, Punyashlok Ahilyadevi Holkar, Solapur, University, Solapur. Sir also joined in this webinar. So on behalf of Department of Chemistry, Karmavir Bharao Patil Mahavidyalaya Pandharpur, I welcome you, sir, in this webinar. The president of this function, the principal of our college, Honorable Dr. K. Shinde, sir, will join with us within a few minutes. Number of the participants are now joining into our webinar. So on behalf of Department of Chemistry, I welcome you all in this webinar. Ours is the first autonomous college which is located in Solapur district. We are working in jurisdiction of Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. By setting, we muted to all. Those who want to speak, they can unmute themselves. This webinar is also going to live streaming on our college YouTube channel, KBPM Pandharpur Learning Platform. And we are organizing this webinar under the aegis of a RUSA Component 8. Ours is the college of beneficiary of the RUSA. Our college has a status of college with potential for excellence from the University Grant Commission, New Delhi. The Department of Chemistry is offering UG and PG course, as well as this department is having a research center. Research students are working in this department. This is one of the leading department of our college. And now, due to the COVID-19 pandemic situation, there is a need of virtual laboratory in almost all the subjects of the science faculty. And to keep these things in mind, this department is now organizing this webinar on a topic, Introduction to Virtual Laboratory in the Chemistry. So once again, on behalf of Department of Chemistry and Karmavir Bharao Patil Mahavidyalaya Pandharpur, I welcome you all in this webinar.
साहेबांना एक फोन करा आणि जॉईन करायचं जॉईन व्हायला सांगा हो म्हणा.
आवाज येतो ना माझं पूर्ण पासून? हो बदल. त्या पीसीला जे लॉग इन आहे ना सर, लॉग इन तो ईमेल कोणाचं नाव आहे? झाले जॉईन? तो पीसी तिथला
केमिस्ट म्हणून तुम्हाला हे करायचं पोस्ट
हां.
केमिस्ट म्हणून
ह्याला येतच येतच नाही याला प्रोसेस. बरोबर. साहेब
हॅलो.
हा साहेब आपण
हा.
सुरू करूया का, कारण रिसोर्स पर्सन जॉईन झाले
बर 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 करा सुरू.
आणि आणखी लोक जॉईन होत आहेत.
बर बर मला काय वाटलं 3 अर्धा तास दिलाय काय असं.
हो नाही, होत आहेत, जॉईन होत आहेत. 1-2 मिनिटात सुरू करूया आपण.
हो हो चालेल.
Now, the president of this function and principal of our college, Honorable Dr. K. Shinde Saheb, has also joined in our webinar. So, on behalf of Department of Chemistry, I welcome Honorable Dr. K. Shinde Saheb in this webinar. Now, with the permission of resource person, Honorable Dr. R. Vijay Solomon, sir, the chief guest of this webinar, Honorable Dr. R.B. Bhosle, sir, and the president of this function, we can start this webinar.
Shall I start?
Yes, sir, we can start.
Yes, yeah.
Okay.
Okay, good afternoon to all. And it's a great privilege and honor to be here to give a talk in this esteemed institution, Karmveer Barav Patil Mahavidyalaya, Pandharpur. And it's a great opportunity for me to interact with the teaching fraternity. And even though we are physically apart, and thanks to COVID, at least in one way, we are interacting through this virtual platform.
Sir, sir, one second. We have prepared one program schedule.
Yeah, yes, sir.
With this schedule, we are now going to start this webinar. So as per the tradition of our college, now we are going to play here a Rayat Geet. It is actually one song, sir,
Yes.
which giving
Yes, please.
information about our parent institution, Rayat Shikshan Sanstha Satara, which is a leading institution who is working for the education field. Now I'm going to play this Rayat song.
सर हां हां
Take the speed.
करा करा शेअर म्हणा हां
रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. कर्मवीरांचे ज्ञानपीठ हे शक्तिपीठ ही ठरते आहे. शाहू फुल्यांचे समानतेचे तत्वमानसी मूर्ते आहे. धर्म जातीच्या पाद गांधींचे मूल्य मानवी जपतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. गरिबासाठी लेणी मोडून लक्ष्मी वहिनी झाली आई. कमवा आणि शिका मंत्र हा तरुणाईला प्रेरक होई. स्वावलंबी वृत्ती ठेवून ज्ञान साधना करतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. दलितांसाठी अण्णा तुमची झिजली चंदन काया. अनाथ जीवा सदा लाभली मातृहृदयी तुमची माया. शून्यामधल्या नवसृष्टीचा निर्मिक तोही ठरतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. तिमिर जावा, प्रबोधनाची पहाट व्हावी, इथे लाभले पंखले उनी, उंच भरारी नभात घ्यावी. प्रतिभाशाली बहुजनांचा वेलू गगनी चढतो आहे, रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे, रयते मधुनी नव्या युगाचा.
Thank you, sir. Now, I would like to request the Head Department of Chemistry, Professor Aryan Zamre, sir. Please make the welcome and introductory speech here. Honorable Professor Aryan Zamre, sir.
गुड आफ्टरनून. रयत शिक्षण संस्थाच कर्मवीर भाऊराव पाटील महाविद्यालय पंढरपूर and Department of Chemistry welcomes in a national webinar on Introduction to Virtual Laboratory in Chemistry under the aegis of RUSA Component 8. Today's resource person, Dr. R. Vijay Solomon, Assistant Professor, Madras Christian College, Chennai. Chief guest, Professor Dr. R.B. Bhosle, Director, School of Chemical Sciences, Punyashrok Ahilyadevi Holkar, Solapur University, Solapur, and our President of this program, Principal Dr. K.S. Sinde, and distinguished participants and all my friends. I am Professor Aryan Zamre, HOD KBP Mahavidyalay, Pandharpur. This pandemic is a
Good afternoon, sir. Bhosle sahib.
on the future of students, not just from the virus itself, but because of its impacts on the economy, education, and the overall health system. Despite the challenging circumstances, we want students to be informed and to get prepared for overcoming it through different techniques.
ऐकायला येत नाही डॉक्टर कांबळे.
हाँ सर.
भोसले साहेबांना ऐकायला येत नाही का?
Different techniques. It is a critical that engage with students not now to start the journey to understanding the virtual laboratory system. The impact of COVID-19 pandemic is observed in every sector around the world. The education sector of India as well as world are badly affected by this crisis. The outbreak of COVID-19 has taught us that change is inevitable. It has worked as a catalyst for educational institutions to grow and opt for platform with techniques which have not been used before. In this current scenario, to outcome the classical methods, some non-classical techniques such as virtual laboratory for conducting practicals online is the need of time. This webinar will be helpful to understand concept of virtual laboratory. This webinar will help us in aspects such as first point, introduction to virtual laboratory, how to conduct practicals using virtual laboratory, and third one, demonstration of online resources. I am confident that at the end of this webinar, we all will find new ideas for conducting practicals using virtual laboratory. I wish you all a very successful webinars. Thank you. Jai Hind, Jai Karne.
Thank you, Professor Zambre sir. Now, I would like to request Assistant Professor Dr. B.S. Londe sir, please introduce the today's resource person, chief guest, and president of this function to the all participants. Dr. B.S. Londe sir.
Hello everyone. Myself, Dr. B.S. Londe, working as Assistant Professor in Chemistry, Karmavir Bahurao Patil Mahavidyalaya, Pandharpur. I extend a warm welcome to all the participants and delegates in this webinar. I take this opportunity to introduce a resource person of today's function, Dr. R. Vijay Solomon from Chennai. Currently, he is working as assistant professor in Department of Chemistry, Madras Christian College, Chennai. After completing doctoral studies in 2012 on designing molecules for optoelectronic applications and probing halogen bonds in base pair, he went to Switzerland and South Carolina, USA for postdoctoral studies. After completion of postdoc, he joined the current position since 2016. Now, he is working on two major research projects. One is from PhD Serb and another from total sanction amount is more than 45 lakhs. His research interests are modeling nanomaterials and excited state properties of molecule, biomass conversion and nuclear waste treatment, modeling of chemical reactions, heterogeneous catalysis, and molecules for solar cell applications. Dr. R. Vijay Solomon loved to teach molecular spectroscopy and quantum mechanics, chemical kinetics, and electrochemistry, basic chemistry, as well as computer-aided chemistry. He contributed a book chapter in internationally recognized book entitled Nanocovalent in Catalysis. There are more than 50 research papers to his credit published in the journals of international repute. He has been awarded with Best Research Paper Award for a number of times, Early Career Research Fellowship, Swiss Government Excellence Fellowship, Professor C.N.R. Rao Young Scientist Award, Best Paper Presentation in various national conferences, and so on. He delivered more than 30 invited talks in different national, international conferences and webinars. With this brief introduction, I extend my warm welcome to resource person of today's webinar, Dr. Vijay Solomon. After this, I would like to introduce chief guest of today's function, Dr. R.B. Bhosle sir. Dr. R.B. Bhosle sir, presently working as professor, and he is also director, School of Chemical Sciences, Punyashlok Ahilya Devi Holkar, Solapur University, Solapur. He did his MSc in organic chemistry from Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad in 1986. He did PhD from Sri Ramananda Tirth Marathwada University, Nanded in 2004, and he started his service in 1987 in Sri Shivaji College, Barshi. Then in 2008, he entered in Solapur University, and up till today, 33 years of service and teaching experience is with him. More than 50 research papers are published in the national and international journals, and 2 reference books in chemistry have also been published by him. There are 6 students working under his guidance and 6 students already awarded PhD degree. Number of PhD theses have been evaluated by Dr. Bhosle sir from various universities in India, and more notably, 2 Indian patents are granted recently. More than 100 papers are presented in national and international conferences. He also worked as in charge director of KRC Library, also worked as in charge director of School of Earth Science, worked as Senate member, BOS member, and currently he is working as Management Council member of the university. He also working as a purchase committee member of the university. Also, he is working as RRC and DRC member since last 10 years. With this brief introduction, I extend my welcome to Professor Dr. R.B. Bhosle sir. And now it's a matter of pride to introduce the president of the function, Honorable Principal Dr. K.H. Shinde sir. Dr. K.H. Shinde sir, presently working as Principal of Karmavir Bhaurao Patil Mahavidyalaya Pandharpur. He completed his MA in Economics in 1983, MPhil in 1989, and doctoral study PhD degree in 1999. 23 students have awarded MPhil and PhD degree under his guidance, and 4 are working for their PhD degree. More than 10 reference books have been published by Sir, and 1 major and 3 minor research projects have been completed. He worked as lecturer, principal, and different posts in Raj Shikshan Sanstha as well as University of Pune. Notably, Sir has worked as Joint Secretary of Raj Shikshan Sanstha during 2005 to 2008. He also worked as BOS member in Economics, BOS member in Commerce, and RRC member of the university. He is a recipient of prestigious award, Best Principal Award of Pune University. With this brief introduction, I welcome you all in this today's webinar. Thank you.
Thank you, Dr. Lunde sir. Now, I would like to request the chief guest of this webinar, Honorable Dr. R.B. Bhosle sir, Director, School of Chemical Sciences, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. Sir, please make your inaugural speech. Honorable Dr. R.B. Bhosle sir.
आवाज येतो सर आवाज
Yes, sir. You are audible, sir.
Okay, sir. Good evening, everybody. Today, the Department of Chemistry, KBP College, Pandharpur, organizing one-day national webinar on Introduction to Virtual Laboratory in Chemistry. I am so glad, and lot of thanks to organizing committee members, Dr. K.H. Shinde sir, Jhamre sir, and others, organize national webinar on this recent and need-based topic. It is very useful and important for all chemistry teachers and students in this COVID-19 pandemic situation. Coronavirus disease is an emerging situation that brought challenges to all sectors, including academia and research. Undergraduate and postgraduate students in chemistry and other science subjects have been affected significantly due to the recent laboratory closures. Experiments have been suspended for long, causing extreme stress to the students. Virtual laboratory is a powerful educational tool that enables students to conduct the experiments at the comfort of their home. An excellent opportunity to engage students with technology and in parallel to avoid a pandemic situation. Experiments are a vital part of the sciences in which students can gain valuable experience in various techniques and develop the necessary skills for their future employments in industry and academia. Nowadays, there is a great need for research scientists with multidisciplinary skills in physical and online experiments. However, virtual laboratories can provide a powerful solution in tertiary education for undergraduate, postgraduates, and doctoral students during this COVID-19 pandemic. I hope today's webinar will become the successful. I request to all participants to take the benefit from this useful and necessary topic. Today, the eminent resource person, Dr. R. Vijay Solomon, will give you the detailed information about this subject in his session. Now, I am very much thankful to organizing committee members to invited me as a chief guest for this webinar. Dr. K. Shinde sir, principal of this college, Jhambre sir, head of the department chemistry, R.G. Kaude sir, Dr. Karale, Dr. B.S. Lunde sir, Dr. J.B. Gujar, and other committee members. Thank you, sir. Thank you very much.
Thank you, sir.
Now, I would like to request the resource person of this webinar, Honorable Dr. R. Vijay Solomon, sir. Sir, please guide us on virtual laboratory in the chemistry. Honorable Dr. Vijay Solomon, sir.
Thank you. Thank you very much. And it's indeed a great pleasure to be here as a part of this webinar, which was organized by one of the leading institutions and great institutions in India. And I thank the organizing committee, head of the department, organizers, and Londe sir, because he has initiated the process through WhatsApp. And then we met, together in the refresher program at University of Hyderabad, and since then we are in touch. So I'm happy to see his face again through this platform, and I thank this opportunity. I thank the management for this opportunity. Let me share my screen. Yes.
Now you can share your screen.
Yeah. Yes. Yes. Is it visible now?
Yes, sir.
Yeah.
Yeah. Whether my full screen is visible?
Yeah.
Yeah.
Yes.
Yeah. Thank you. Okay. So you like it or not, virtual laboratory is becoming a reality in nowadays, because we are in a situation where we are no longer meeting the students. We as a faculty members had a lot of struggle when we moved from classroom atmosphere to the online platform. Okay, it took for us to to set this particular tone and tenor for this teaching. It takes 5 to 6 months, but finally we are happy with the online teaching, and we can meet students through virtual platform. Excellent. But it is a paramount task for us to conduct the practicals. Very, very tough, especially subjects like physics, chemistry, biology. Very, very tough, and it's a tedious process. And in that channel, if you think about, we need to engage students we need to conduct practicals, and syllabus is already defined, and we need to go in that fashion. So virtual laboratory helps us to realize the importance of the concepts that we would like to drive into students. Okay, let me start with the definition. If I ask you, any one of you can tell about your experience in virtual laboratory, or in your view, can you define what is virtual laboratory? If I ask anyone, you can just unmute and you can talk. What is virtual laboratory in your view? Anyone, any participants? And from there on, I can take you through this particular topic.
So it is not real laboratory.
It is not real laboratory. Excellent.
It is online mode of practicing experiments,
Online mode of practicing experiments. Excellent.
like simulations, etc.
Simulations. Yes. Then. Okay, they are all peripheral information. Like, what is the definition? Okay. Before going to that, let me thank Madras Christian College, one of the top colleges in India, and for having me as assistant professor. And I thank my principal, Dr. P. Wilson, and my head of the department, Dr. E. Ayyappan, and all other faculties for encouraging me to look into the virtual laboratory when the lockdown came into picture. So my department asked me, since I am from a computational chemistry background, and I used to take computer-aided chemistry. So they asked me, can you think about anything in that line? And that eventually lead me to look into virtual laboratory. So far, I never thought of this. Okay, I thank my college. And the definition goes in this way. If you look at that, the virtual laboratory is an interactive environment creating and conducting simulated experiments, a playground for experimentation. So here, the important keyword is interactive environment, because when we really think about doing something online, we usually used to do taking some videos, sharing with the students, and or we will go to the laboratory and perform the reaction, perform the experiment, and going for a video capturing and then streaming it through online mode, and then let the students can see that. But the virtual practical definition goes in this way. It is an interactive environment, which means the computer should interact with the users should interact with the computer. So that is the first definition. So interactive learning environment by using animations and simulations for abstract topic, where students become active in their learning, provide opportunities for students to construct and understand difficult concepts more easily. Here, all these things are already recorded there, okay, in the literature, and I have quoted from there. So some of the advantages are available with them. Students are more active, and many of our teaching fraternity are not willing to accept that, because we always believe that students should come physically, stand in front of the Bunsen banner, and then do the experiment, come and report us, and then we need to give signature. This is how we practice the laboratory experiment so far. But here, when the task is given to them, and we know that all the students of this generation are tech savvy persons, which means they are very good at technology than us. Okay, so they used to go and click different options available there, and then they will come up with a lot of creative ideas, and that makes them to be very active in learning part. And computer based experiments are mostly used in abroad, where they are given as a pre-laboratory course. Students like to work with their simulation program. They tend to enjoy working with it, because always they are trapped with mobile phones or laptop, or they will be using all sort of gadgets. They found it motivating, and they realized that it created a lot of experience which they believe could be remembered more easily. So all these things are recorded in the literature. Virtual laboratories have been used to provide students with the visual representations of chemistry concepts and to prepare students for the laboratory sessions. So here you need to understand that to prepare students for their laboratory sessions, which means that we should have a physical laboratory sessions, even though we have virtual laboratory. But this virtual laboratory will help us to give a platform where students can understand the concept in a more clearer way, and they used to perform, repeat the experiments, and they can learn of themselves. Okay, so potential benefits of virtual laboratory: students would feel more relaxed and comfortable in the laboratory. Yes, of course, the moment that they got the salt in their hand, and you can see that, a lot of sweating will come from the student's face, and they will be struggling. They will be fumbling there when the time crosses 2 hours, 2.5 hours. When the instruction is given, come and report you what is a cation and anion. Definitely, they will have a very tough time, and students would be more likely to assemble and use apparatus in the correct way, leading to more meaningful experimental results. And most of the virtual practicals which we are going to look at in this session will help us to understand how to use the apparatus. Okay, students could devote more of their attention to the chemistry concepts involved in the experiments because they would already be familiar with the procedural aspects of the task. All these things are beneficial of the virtual laboratory. Before getting into the topic, I need to give a disclaimer. I completely agree with all of you that we, as a country, as an institution, as a teacher, as a student, are not prepared for this pandemic. Very frankly speaking, we are totally unaware of this particular situation, and we never imagined that this situation will arise. Even though the virtual laboratory concept is quite old, still it is new to all of us. Situation demands us to venture into this exercise, and still we are struggling. I'm just telling about the teaching transformation that has been taken place in the recent past. In this session, we're going to see some of the experiments which will give some hope to conduct practical classes virtually. I really mean some hope. Let us see. Okay, virtual laboratory and reality. If you think about the number one task in the real practical, like we used to have a laboratory session for 3 hours or 4 hours. It depends upon UG or PG, and we have a lot of works to do during that time. We'll ask the student to prepare the solution. We ask the student to write the procedure, and coming up with the tabular column, do the experiments and filling up that. But in virtual laboratory, if you look at the practicals that we are going to see, everything can be finished within 5 minutes or 10 minutes or 20 minutes. So the real problem lies how to manage the time, how to keep the students engaged with us in practical classes. That we will do. So without taking much time, I will straight away take you to a virtual titration first. Okay, and there are many websites available for that, and I pick one of the most robust website which can be given to the students. So whatever the experiments that I'm going to show are all are given to my students in my class. I'm teaching physical chemistry, so I have given around 6 to 7 experiments to my students, and I'm going to demonstrate that. And apart from that, I'll have some other experiments in inorganic chemistry and analytical and organic chemistry as well. But let us see. First, I will just take you through to the virtual laboratory. If you want to do the practical with me, you are free to do, and I can share the link. Or I will just straight away, I can go to my website and start doing the practical. Okay. Then the first one, I'll stop here my PowerPoint. I'll go to the website. Yeah, hope my screen is visible. So
Yes,
now I am in a place where American Chemical Society gave a beautiful website and virtual chemistry and simulations. They listed many websites here. Okay, I'll just copy this link and I'll put it in the chat box so that uh, you know you can also make a note of it. At the end, I can also share. This is a very good website, and they have collected a lot of websites which includes more than 600 experiments. 600 virtual experiments are collected here, and we are going to start with only a very simple titration screen method. This experiment was given to students when they enter into the virtual mode practical. Very first class, we have given this particular training, how to do a titration virtually. So I'll just take this. Yeah, this is the first one. Whenever you click this one, this will take you to this particular experiment. Once again, I'll start afresh. Okay, so titration screen experiment, and here you have some guidelines for teachers. Titration screen experiment teacher notes, but I'll just straight away go and click titration screen experiment. Okay, so I already logged in, so I'll log out first. I'll click titration. So here you can go for login and register. And when I click register, register as a class or register. Okay. When you want to register your students, what you can do, click here and you can give number or name. Let's say Ajay. Okay. So I'm just typing few numbers, names. Okay. Vijay, something like that. I have typed, and at the end I can take 30 students. If I click submit, this will give a unique ID to each of the students. Okay, what we can do, we can save this as a PDF and we can share it to students. So each of the students should have one unique login ID, and with that login they can go ahead. Okay, I'll straight away go to login. So if I have number, I can type. So I will go to titration. I'll just log in. I register. I'll just register. If I register that, I'll get some number here. Okay. So return to screen experiment. Usually this number we can give for students. Any number of students can be given, and we can start at this level. There are 4 titrations available, and the titration concepts are very simple. This is a basic first BSc level. And here it gives all the instructions and scores. If you click next, to start this level, you have to watch a video, which is around 3 minutes, and 100 points for just watching the video. So this is a video. I'll just, in a nutshell, I can tell.
Breaking news.
Yeah, here a lorry crash causes acid spill on the river. So acid spills on the river, and the 3 samples, A, B, C, the 3 places, they have taken the water sample, and we are going to do the titration, and we want to find out which one is acidic, which one is having a higher concentration through titration mode. So that is our understanding. So you can watch the video which gives information about what is acid, what is base, what is pH, and so on. And I'm not going to look at that and how to do the reaction and so on, experiments.
The unknown concentrations of acid in the samples collected from the contaminated river. You'll need to carefully add just the right amount of acid to the alkali solution to reach the neutralization point and judge when the indicator color changes.
Okay, once that video is over, we'll just click next. So if you, if a student or if you do the experiment, it says that green color. I hope you were watching closely and you know about acid-base titration. Click finish. Then I say that here you have a review lab book, which means a PDF version of the lab record is automatically generated here. So as soon as you complete the practical, your lab record is already written. You can simply download the PDF and upload in the Google Classroom. That is the idea behind that. Okay, this is a review note. Next activity is we have seen a video, so we want to answer some of the questions here. For example, hydrochloric acid fully dissociates when dissolved in water. The pH of water is approximately 7. Then the student should do this quiz. When an acid and alkali react to form water and salt, this is called a neutralization. Ionization point of neutralization, burette reading. Okay, an indicator helps us to see the point of neutralization during a titration experiment by causing a color change. A titration experiment can be used to determine the unknown concentration. We can just click and drag the right answer, and then we can check. If everything is right, this will give right. If it is wrong, this will give wrong, and then we need to do it again. And you score 100 points. Whenever you cross one stage, it will give automatic score. The next activity is we need to look at the pH. We need to choose NaOH, a basic, a acidic, and then a neutral. Then again, I am clicking check. Yes, successfully done. Then select all the compounds that are acidic in nature. So I need to pick HCl, H2SO4, HNO3, and then check. Fine. But the student will take some time. Eventually, he will take some time. He will learn things of his own and then proceed. Here, true or false? The phenolphthalein indicator is not affected by the pH of the solution. False. The phenolphthalein indicator changes color close to the end point of neutralization, which shows the end point of titration. Yes. When adding acid to base, the phenolphthalein indicator changes color from colorless to pink. If suppose I'm clicking wrong here, okay, it used to be false. I'm just saying the check. Then say that at least one of your answer is not correct. Try again, minus 10 points. So here something is wrong. So minus 10 point. I'm just clicking OK, and then I'm just revert to the correct one, and it says, well done, you have answered the question. And every time when you complete that, the score will be recorded. Here you can see points available and total points 290. I'm in the third stage. Okay, next activity. Now we need to wait. Okay, so what we need to do here, electronic balance is available here. I need to keep the tray here, and then I need to tap. Then I need to take the spatula, and then I need to add. The question is given here, accurately weigh out approximately 1 gram of sodium hydroxide. The task is 1 gram I need to weigh. So I'm just adding that. You can look at that 0.42, 0.63, 0.84. Then I'm just going a little bit lower amount, 0.93. So I'm just going to add 0.01 gram. Upon each click, a 0.01 gram is added. Because the task is I need to weigh accurately 1 gram. So 1 gram I weigh, and I am going to check. Well done. This is the amount of sodium hydroxide that you will use to make your standard solution, and so on. Click finish. Then next, the amount is weighed. So now we need to do that. You can read the instructions. The salt is already taken here in the beaker. So what we need to do, we need to keep the funnel here in the SMF, and I need to add water to dissolve the NaOH. And again, I'm just going to add some water. Yeah, yes, and automatically it shakes. I didn't do anything. Then immediately a dropper will appear. Now we need to make a note of the meniscus now. So what I'm going to do, I'm going to just keep the dropper here. I'm adding a big drop, and then a small drop. And you look at that, the magnification window appeared here, will help us to keep the meniscus. And I'm just going to add everything in a drop wise. And every time you do the right hand side, you will have the instruction what you need to do. So I'm going to add. Okay, then I am just checking here. Now this says that you have added too much of water because the amount is crossed. So what I need to do, I need to restart. Okay, restart. I need to add carefully, so that I need to keep the mark level, and then I need to prepare the solutions, make up the solution in a right way. So I need to have patience. I can repeat it in a number of times, so students can learn how to precisely make up the solution. I think now, yeah, now this is like, you are right, you are correctly prepared the sodium hydroxide solution. Next activity, you scored 90 points, and you can find 480 points that I've scored here. That will be appear at the right hand bottom. Next activity is to calculate the concentration more. Now we need to understand the concepts Here you have given an indication what is the periodic table is here for help, but we know sodium 23, the mass oxygen 16, and hydrogen 1, and check. Yes. Then we need to find the amount of substance. So amount of substance in mole is given by mass divided by molar mass. And then they say amount of substance mass divided by molar mass, 1 gram divided by 40 gram, then 0.025. Then we need to find the concentration. Concentration is given by the amount of substance into 1000 divided by volume. The same thing we need to do the concentration. We need to find amount of NaOH, 1000 is given, volume is 250 ml, and what is the concentration? 0.01. Click and finish. Now my score is 580, and I need to do the next. Now what we need to do, we need to prepare the solution for titration, which needs our pipette should be rinsed. So this exercise is helping us to understand how to rinse. The solution is taken in the beaker. What we need to do, we need to dip the solution, keep on pressing. At particular point, you will have this rotate button enabled. You click here, and it is rinsing. I'm not doing anything. I'm just, it is rinsing. Okay, and then we need to drain out the solution in the waste beaker. Here, waste beaker is given here, waste beaker. So this exercise is simply how to rinse a pipette. Check. Yes. Now what we need to do? Now the instruction is given on the right hand side. Now transfer 25 ml into the flask and 2 or 3 drops of indicator. So I need to take this, insert here. Then I just press and hold, and just click that, and then I'm holding that, and magnifying window is there. We need to click. Okay, so I can remove here. I can place it here and then drain out. So 25 ml of NaOH is taken here in the burette, and then I need to add indicator, 2 to 3 drops. So I'm adding 3 drops. Check. You are right. You correctly set up the flask. Now the next here, what is my score? Next, what I need to do? You need to rinse the burette and fill that. You will be testing a water sample from the site B. So in 3 places they have collected the sample A, B. Here the acid spill occurs. So B, C, and D. 3 titrations we are going to do, and we are going to compare what is the result. How about the acidity of the water sample that we are going to take. So click on B side. So I'm just clicking there. Here, to prepare the burette solution, you need to rinse it and then fill it with the sample from side B. Start by rinsing the burette with distilled water. As a safety precaution, always make sure that the top of the burette is below eye level when you fill it. So first we need to fix the eye level. Okay, so here is the eye level. So I'm just adjusting this knob, and I'm just fixing that. I want to add the water into the burette. I'm just checking. Yes, that is right. Next, what we need to rinse the burette with the sample, same sample water. So I need to keep the funnel. Then I need to add that. Just rinsing it. That's fine. Now what we need to do, fill the burette with the sample. Remember to close the tap when filling the burette. So first thing is we need to close the burette, which can be done using this one. Yes, I am doing. Then I can fill this. Okay, remove the funnel afterwards to ensure the fill level remains constant. So I need to remove this. Check. Yes, it is right. Then now we need to adjust to find out the what level in the burette. So what I need to do, I need to adjust the eye level, because we need to ensure the student is looking at the number in the burette when keeping the eye level is the same with the reading. So I need to adjust this eye level, adjust, and then yeah, that is right. We can do the experiment. Again, the 100 points are added. Now we need to do. Now we need to go for the titration. Here, if you look at the titration, the first point is we need to make the initial reading. What is my initial reading? So initial reading I need to do here. There are some tips will be there, but you can look at that. What is that? Like 10, 10.1, 10.2, 10.3. So here 10.25, and I want to check it. Yes, this is 10.25. Next, when you finish this, then automatically your start and stop button will be enabled, and you can click this start, and you should be ready with your cursor on the stop button, because the titration is on. And we know that the color change from, yeah, I stopped that. Color changes from pink to colorless, and I just checked whether the point at which I stopped is right or wrong. It says yes, that's right, correctly done. Next, I need to give the marking here. What is my marking? 25, 25.5, 25.6, 25.7. So I can write 25.70. No, that's wrong. So bureau trading, again I need to look what is the trading. It's like 25, 25.1, 2, 3, 4, 5, 6. Then this should be 6.5. Let me check here. Yeah, that's right. Now what I need to do, I need to subtract these two. What is the value? 25 minus 5 is 15. Point, you have 40. Check. Yeah, that's right. So this is a trial run, and then for the next run, automatically the initial reading is fixed. Only thing we need to start the titration. I think we can keep this. Let me check for that is right. No, that is not right. You have added enough of the sample. Bureau, when the color change only just persist. Trying to. Yeah, now that is right. So here the student can understand this particular experiment, when to stop, where to stop, how to adjust the bureau, how to adjust the bureau trading, how to read the bureau trading, and so on. So this is right. Then we need to write this 27.65. Let me check. Yes. Now I need to write what is that? 16.30. Okay, I need to repeat the same thing here one more time. I don't want to repeat it here, but the point here is you can repeat this. This is for the sample C and then sample D, and you need to compare, and the student should write the comment about the quality of the water sample with respect to the amount of acid present in the system. So if you click this, this will give a total points in the each stage, and you can download this particular PDF of lab book. If you download, yeah, this is downloaded here. So I'll just share that. I'll share that. It will be in downloads. I'll open it just. So this is the lab record notebook which has been downloaded now. So how many attempts? What is that? weighing one attempt, what is the procedure, what is our concentration, what answer that I gave, how to keep my eye level, all these things are available here. And then I need to give, I haven't completed this session, titration analysis I need to give, titration experiment I need to give at the end of the 3 titrations, and review I need to give what is my performance and how I view this experiment and so on. These things students should fill, and it will be served as a lab record. Once this is downloaded, they can simply take this particular PDF version and upload it in our Google Classroom. And this is a very simple experiment which is given in the RSA website. I'll just close. I'll just go back to my screen. Okay, so this is how we need to do. And I am just showing only one titration here, but we have 4 titrations here. You go back to this titration level 2, determine the amount of aspirin in a batch of tablets by performing a weak acid strong base titration. The third experiment is determine a concentration of ammonia against by performing a strong acid and weak base. And the fourth one is titration level, determine the amount of iron in a batch of diet supplement tablets by performing a redox titration. So all 4 type of titrations are given here, and student can finish one after the other, and then he can submit the PDF version. So this is a very easy way to introduce titration to students. So this is a very simple, basic idea about a virtual practical. It is highly interactive, and students will enjoy. Our students have thoroughly enjoyed the session, and they feel that, sir, it is very easy for us to understand how we need to do the apparatus. Keep the apparatus, how to handle the apparatus and all these things. Even though we have completed our titrations in the first year, third BSc students said that they thoroughly enjoyed this particular experiment, and I asked them to do titration level 1, but they have completed titration level 4, and they said that this was one of the amazing experiments we can have it in our undergraduation. So this is very simple experiment, and I hope this will give an idea about how a virtual practical should be conducted. When I have started my discussion, I said that engaging the students will be a tough task in virtual mode. So what we are doing here in our college, especially myself is concerned, I will take first 20 minutes or 15 minutes, I will teach the basic theories corresponding to the experiments that are going to be performed on that day. And then I'll give a break, and I'll give 10 questions, basic questions with few calculations. Let them go back and do the calculation and get the concepts thoroughly understood by themselves. And then after 40 minutes of break, I'll just ask them to regroup. I will explain how to do the experiments in a laboratory, as usual in a laboratory. And then I can ask them to, okay, you can write the procedure, or we can give the procedure. We will ask them to put the tabular column, calculation part, everything we will explain, and they have to do. So in the manual lab notebook, they used to draw everything. We will give another 40 minutes break. And when they come back, and we will ask them to go to the website and perform the reaction. And it will take only 10 minutes or 15 minutes to complete the physical chemistry experiments, especially. So once they finish that, they can draw the numbers from the experiments. They can manually enter into the laboratory notebooks or observation notebooks, and they will do the calculation, and then they will take photo, convert it into PDF, and then they will submit as an assignment in the Google Classroom. This is how we are conducting practical. So we need to strike a balance between the theory or theory behind the practicals, along with the type of experiment that we are going to give to them. So that is more important. So this is a very simple example which I have given as a first practical, and I urge you also can use this particular website, and we can go and give this as a very first virtual experience or virtual experiment to students. Okay, then moving on to the other aspects, I would say inorganic chemistry. If you look at that inorganic chemistry, I have taken that there are many websites available, and some of the websites are funded by Government of India, and many premier institutions, they have come up with some of the virtual practicals for us, and we can freely use it. Okay, so this one is like inorganic qualitative analysis. I'll only thing, like a teacher should take some time to explore all the options available, and they are not customized one with our wish. They have given some task, they have given some tests and analysis. Only thing we need to understand that, and we need to understand the limitations as well as the salient features of particular experiments, and we need to sit, we need to arrange everything in order and before going into the virtual practical. Okay, so here I have I'll just take particular website. I'll just refresh that. Okay, here a sample is given here. This is like qualitative analysis of cation. So here smell. If you click smell, then you can find. I'll just post this link also in the chat box, so that sidewise alongside, if you want to try it out, you can try. Yeah. So if you have any questions and any other clarifications, if you want to have, please stop me at any point, and you can free to ask, and I'll try to give answers then and there, and then I can proceed. Okay, here I can just smell test, dry heating. If you look at the dry heating, then I can just take a pinch of salt I need to take. Yeah, I think, let me check the other option. Okay, well, very simple. Okay, I'm just taking a small portion of a salt from the given sample, and then I want to smell it. You can add water. You can touch that, there is no smell. It gives, all these are unknown sample, and through that you have to test all the tests available here. Dry heating, charcoal cavity test, cobalt nitrate test, flame test, and borax bead test. You need to do that. Only thing you need to play with that. Okay, for example, color test, and just like maybe lead, that they are giving some clue for this particular one. When you have a help symbol appear here, you can click that color test. And also each of the websites are designed for a separate purpose, and working with those websites you need to have some practice. So what I used to do before a practical, I used to spend at least an hour with the website, just click all the features, and I'll just try which is working, which is not working. I should have a control over the experiment. So sometimes their websites may not be updated. Sometimes the websites might be down at that time, and some of the aspects may not function well. All these things we need to have understanding, so that we can deliver it in a better way to the students. So this is one such analysis I can think of. I have a list of softwares and other things. And another a premier website which I'm using for my BSc chemistry, physical chemistry experiments, especially physical chemistry experiments, is Amrita University. So that website I can take. Okay, let me just give one example from organic chemistry. So I'll just go back to chemical sciences, and I'm sharing this website with you through chat box. Okay, so here the Amrita University Virtual Laboratory came up with many virtual experiments, especially for physical chemistry, organic chemistry, inorganic chemistry, and advanced chemistry laboratory virtual lab. All these are virtual lab. Here, some of the experiments, they have only the simulations, which means no interaction was not possible there with the experiment. Some experiments, they have a simulator where an individual can work with that. So let me start with the organic lab. There are many other things, detection of functional group, and then column chromatography, fractional distillation, and so on. But I'll just start with estimation of aspirin. Here, they have given objective to determine the amount of aspirin in the whole of the given solution. And they have given an introduction, what is aspirin, what is the importance of this one, their preparation, and so on, which I'm just giving here. The students can easily go through this and how to do the calculation part, and everything is given here in the very first part called theory. Then in the second tab, if you look at the procedure, what you need to do. Okay, click add aspirin button, click add NaOH, and so on. And the third point is self-evaluation. One thing is very common in most of the virtual laboratories is the kind of quiz questions they ask to check the students' understanding on that particular experiment, because they have been given the procedure, they have been given the theoretical basics, and it is highly necessary to check their understanding. So self-evaluation, you can click a type of titration where in the analyte contains all other reagent except the sample is called. What is that titration? An IUPAC name of aspirin. All these things they can simply click and submit. If it is right, it will be given in the green color. If it is wrong, it will be delivered in a red color. So this is given, and then the next one is simulator. Here it requires a login, and it is a free sign up. Anyone with a institution ID, we can go and sign. I'll just go to you, and I have given my MCC ID. I have my own password for that, and I'm just clicking login. And it is made up of the Flash player. If Flash player is not working, you can go to the top top of your web bar, so where you can type www. You can click here, and then you can enable the Flash player. So once this is ready, and here a self-explanatory guidelines or instructions are given for us. For example, select weight of aspirin from the slider. So the slider is here. You can see 2 gram, 3 gram, 10 gram. Can you see that? Yeah, I'm going to take 5 gram, let's say. So the first step is choosing aspirin. Click add aspirin. Okay, add. Look at that. 5 gram aspirin is added into the reaction container. And then what we need to do, click on add NaOH. Now I'm just scrolling down here. You can find add NaOH. And just add NaOH. I am clicking here. You can see NaOH is added here. Then what I need to do, I need to, okay, I'm just adjusting the panel. Here it is next. I'm just clicking next. The fifth step is click on reflex button to reflex the content for 15 minutes. Then click next. So I need to say that reflex button. And here you can have clock is available here. I'm just clicking reflex. It will not take 15 minutes, but simply it will show 15 minutes is there. Okay, you look at that when you are reflexing, the water is given from the pipe, and it is going to the condenser and coming back with the water here. It is just pouring down into the sink. Everything is animated way here. I'm just clicking next. Then transfer solution to the 250 ml flask. Okay, I'm just clicking transfer solution. So from the reaction mixture, the solution is transferred. Then make up the solution. Yes, I'm just going to make up the solution. Yeah, once the solution is made up, then I'm just clicking. Select the volume of aspirin from the slider. So whether am I going to take 20 ml of aspirin solution or 10 ml and so on, I'm just going to take 15 ml. pipetted out. So we need to pipette out 20 ml, 15 ml. I just picked 15 ml, but we can vary the amount of volume of aspirin to be taken into the conical flask in a different way to the students. So what we usually do, we will ask the student to go for 10 ml, 11 ml, 12 ml. So we will give the different ml to different students so that they will not get the same the values during the titration. Next, so I need to do the titration. Here a thio solution is already filled up in the burette, and the speed of the drops, we'll just start. There are two things. One is we need to add starch, and another one is start. So what I need to, I'll just adjust the knob here, speed of drops, okay, 0.5, and start. You can see here the volume will be appearing here. It's like 0.4, 0.5, 0.6, and so on. And then here the drops are coming from the burette, and I need to keep ready with my mouse on the stop button because I need to stop at a particular point, and then I need to add starch and I need to continue the titration, which I'm going to do now. I am carefully watching the color of the solution because I need to stop the reaction at a point when the color changes from a pink or red to colorless or white. Then I need to add starch, and then I need to continue the titration. And the volume of aspirin that I have taken is 15 ml, and I need to wait for that. Yes. And the good thing is, in between, if at all you want to click add starch, this button will be disabled, so we cannot add that. So let us wait. Yeah, the point came. Now it says that please add the indicated starch. The color changes from red to this. So I'm just adding starch. Immediately you can see that color is turned to straw yellow to dark blue. Then start the titration. Yeah, immediately it came. The value is 17.2. And then we can ask the students to go for the calculation, and they can complete the calculation and they can give the result to us. We can enter here and we can submit the percentage of aspirin. Everything, calculation part and everything is given here. If you click this procedure, click this theory at the down, what you need to do, principle, and then how to do the calculation, and everything is given here. And we need to teach the students this particular background, and then we can ask the student to submit the laboratory notebook. This is how a small experiments can be performed. There are many other experiments available here. Estimation of glucose. In a similar way, we can do estimation of glucose simulator, and we can do the same thing reaction here. And there are many adjusting knobs here through which we can play. We can give different sorts of amount to different students, and we can have a record over it, and so that students will not get the same value for the same titration. Okay, so this is a simple example in organic chemistry. There are many other websites, as I showed that in the very first website that I introduced is nothing but the ACS Virtual Chemistry Laboratory. So there are many other websites available where we will have more than 600 experiments available. Only thing, they are not customized to our syllabus or our understanding. So remaining things, and certain things here are a simple a video or animated video. For example, if you look at that as a fractional distillation, if you look at that here, theory is there, procedure is given, self-evaluation here, animation is here, and no experiment. In the previous case, we have a simulator. If you look at the animation is just what is fractional distillation, and then a video will be there, cyclohexane and toluene, ethanol and water, and there is no sound available. So it's everything is self-explanatory. A student can watch this the entire video. Okay, click any one of the label we can take. The system is given and how to set up the reaction, and everything is here. In the bottom, you can find place the RB flask in the heating mandrel. Every instruction will be appearing here. Fix a fractionating column and an adapter on the top of the RB flask. By definition, this is not a virtual laboratory, because virtual laboratory should be an interactive way. A student should interact with the computer and do that. Here, nothing is there, but everything is in a graphical way or animated way is given, which will beautifully explain how to do a fractional distillation, or the other experiment is giving steam distillation. So this can also be given, and you can ask the students to just visualize how a system can be set up in a real physical laboratory. Okay, so I don't want to continue this, just I want to introduce this. And if you look at going back to the similar way, inorganic chemistry, they have few analysis are given here. They said water analysis, determination of chemical parameter. If you look at that, whenever you have a simulator, yes, you have something to do. Okay, so when the simulator is there, this is a water analysis, determination of chemical properties, and you have a panel here, and you can play with that. Okay, and the instructions are given here. What you need to select the titrant, adjust the speed of the drops from the burette, adjust the molarity of the titrant, select a definite volume of water sample, and then go on. And they have also given the tabular column. They have given the titration, EDTA titration. They have given the titration procedure results, and even in the real laboratory, what we need to do, everything is given here. And you can simply ask the students to go through, customize experiment for their wish. Okay, this is also possible here in inorganic chemistry. And here I looked at what is estimation of barium or estimation of nickel. If you click estimation of nickel, again there is no simulator, but animation is here. The animation will help us to understand how a nickel estimation of nickel can be done in a practical laboratory. Only thing the customer or the user can choose. Okay, I am just going with the 20 ml. So pour the selected volume of nickel in 100 ml, 100 ml SMF. And we don't want to do anything, just we click that, and then it will automatically do what we need to do. And then at the bottom, they are giving an instruction. Even a small thing, keeping a funnel, using the glass rod, and pouring the solution alongside the funnel, using the glass rod. Then we need to rinse the solution to make up. Everything is given here, using a wash bottle and so on. So like that, also few websites, few experiments are designed. So something is better than nothing. That's what I would like to say here. We cannot get 100% customized experiment which is of our understanding, but I agree to a certain extent we can use these things as a part of virtual laboratory, so that the learning can happen in an uninterrupted way. That is the understanding there. Okay, what I feel in the best part is in the physical chemistry laboratory, they have done very good stuff here, because most of the practicals are accompanied with a simulator. Let's say spectrophotometry. I'll just click the simulator. Here a calorimeter, photometer is given here. A cuvette is given here, and we can click here. This will open. I'm just keeping a blank here. Press here to close, record the value. Okay, and I have that, I'll just click here, blank solution. I need to take here, I can adjust the nanometer 350, 355 according to the solution. The solution knob is here. I'll just remove this, remove. Okay, then they have given unknown. We have a known concentration. This known concentration we can adjust here. The adjusting knob, which solution you want to take, we can choose it from here. I'll close here. I'll click here. Okay. Let me refresh. Yeah. So here you have ferrocin, crystal violet, rose bengal, cobalt 3 chloride. So any solution you take, and according to that, the solution color changes. And you have a blank. You can have an unknown. We can have a known. And alongside, we have theory of this procedure, what you need to do, how to do that. Self-evaluation question always given here in this one. And we need to go to simulator. And we can choose, and we can give, and calculated concentration we can give, or we can ask the students to give go for a different concentration here for a particular solution. Ask them to enter the values. Ask them to fix the filter, which nanometer filter we want to have, and based on that, this will give a display. And ask the students to note down the display, and they can enter that into the system. I mean the laboratory notebook. Okay, so in that way we can use this. This is a wonderful experiment, spectrophotometer, and some other thing. Okay, cryoscopy. We have done something called transition temperature, or we can say that the RAST method. All these things are possible here. What we can do, we can have benzene. We can take here. This is a temperature, and we can have benzene. You can adjust the knob, and so that the amount of benzene, everything is solvent here. Okay, I'm just taking here solvent, immersed into a cooling water bath. Usually in our laboratory, we used to take up a system where a beaker filled with water, we will heat the solution, insert the RAS tube or a boiling tube, which is fitted with a thermometer and a stirrer. Okay, and then we will take naphthalene and biphenyl. We will just heat it up the solution, solve the salt, and it will be into the liquid state. Then we will just ask the students to keep on stir the solution to cool down. So the same thing we can do that. We can switch on the solution and the system, and then you can see that the temperatures keep on reducing. 5.5. Then we need to switch off. We need to take up the solution. We need to take a solute. We have benzamide and camphor. Let me take camphor, and I can just give a different amount to different students. 4.24 gram. Then I'll just switch on. So it is added to the solution, and then the stirring taking place. It is immersed into the cooling water bath, and then try to find out the temperature. What happens when a solute is added to a system? And then we have a theoretical procedure. What is depression in the freezing point? And we used to tell that what is del TF, and all Raoult's law, partial vapor pressure, all these things are there. With that, we can find the molecular weight. Usually we will do the RASP method, 1000 into Kf into Wb divided by del TF into WA. So based on that, we can do the experiment. They are also giving an assignment to students. What happens? Some of the questions are there. hypothetical questions, or some of the questions are derived from the experiments, which we can use it for our understanding or as a part of a viva. So this can be done here with the physical chemistry laboratory, and this is an excellent one. Then we have the same way. Ibioscopy is nothing but again the boiling point. The same system we can use. Only thing we can say, go for a boiling point, because this will be a heating water bath. The same solvent we can take, and we can go for this. A boiling point can be given here. Every procedure is given here, and according to our wish and according to our requirement, we can slightly modify that and slightly modify the content here. Within the available content, we can go and do the things that we can do here. Okay, that is a point. So I said that we cannot simply take the system and we can use, but we can slightly customize what is given there. With that, how we can use, how we can profitably derive some information for understanding. Okay, that we can do. So this is also possible here in physical chemistry. And here you have a EMF measurement. Of course, you can. Okay, sorry. I'll just go once again. I'll once again go to this particular Amrita University. Okay, this estimation of this chemical science. I can go to physical chemistry laboratory. Here you have, let me check whether this is coming, or we have other thing, verification of Tafel equation, determination of viscosity, calorimetry, heat of neutralization. This we have done. You can go and click here. Okay, this is again a beautiful experiment which we used to do. Heat of neutralization, we can take HCl. Of course, the theoretical background, procedure, self-evaluation, everything is given here. And what we need to do, we can take HCl, and here you have a cross section. If you look at that, a cross section is given here. We can start. So here a stirrer is keep on stirring to note down the temperature. To get the constant temperature of the solution, we need to wait, and the time is started here, and we can ask the student to note down the time for every 30 seconds. If you look at this particular experiment in real time, it will take around 1 hour for the students to work. But here everything, even though it says 49 seconds, 50 seconds, it will be done in a minute's time. So this particular experiment will run for 4.5 minutes, and then try to find out what is the temperature. Then what we will do, we will take NaOH and try to find out the same temperature. And then we add NaOH and HCl, and then what happens to the system, we would like to understand the temperature. And before that, the first step is the calculation, water equivalent calculation, for which also we have a separate experiment. So we can couple these two together, water equivalent calculation and the heat of neutralization, and we can ask the students to go and perform this particular experiment, and they can note down the values in their observation notebook, and they can go ahead and calculating the heat of neutralization of this particular reaction when HCl is mixed with NaOH. Just let us wait for 4.5 minutes. Because in between, if you want to click any other sample, everything will be disabled. So we need to wait for the 4.5 minutes so that the next sample will be enabled. Okay, once this is done, now you can see that the second option is enabled, NaOH, and click start. So the initial temperature of the HCl is around 29. And now we need to say it started with 31 and now it is 30. Because we want to get a homogeneous solution with a temperature which is constant for a while. So we need to do this. If you take NaOH, the temperature is keep on decreasing from 30.1 to now 25.5 and 29.5. Now it's 29.3. Now it's 29. It started decreasing 28.7. Yeah, in between, if you have any questions or suggestions or clarifications, we can talk because we need to wait for 1 more minute. Now the temperature is 28.1.
For this university website, no, you have registered, but how can we register there?
No, we can register. It's free. It's free. It is funded by Government of India. Government of India has taken an initiative to come up with virtual laboratories in the year 2010. And some of the premier institutions like IIT Delhi, IIT Bombay, and some other deemed universities, they came forward and they got funding from MHRD, and they prepared all these things. It is from taxpayers' money, and we are free to use these sites.
Okay, sir.
Yeah. Thank you. Now, like once the 4.5 minutes is over, then we can say that now we need to go for adding these two solutions. And we can ask the students to note down what is this temperature and what is this temperature. This is like 29 and this is 28.1. And now we can click ask them to do with the mixture and start. And the graph, even if you don't want the graph, we can click hide. This graph will be disabled here, but we can have a graph here. And the temperature starts from 35.7. This is again the 4.5 minutes. So altogether, the student will spend only 4.5 plus 4.5 plus 4.5. And the remaining time, he or she will engage themselves with the understanding of the concepts. And you can see how quickly the temperature is drastically, coming down. That is recorded, and we can ask the students to go for recording for every 30 minutes, and they can do the calculation and so on. Whatever the examples that I'm giving, everything is free to use. That doesn't require any of the login credentials from your part, any payment. But I agree, certain virtual laboratories which are there will demand some money. As a college, we can have a package and so on. But I do not have much idea about the commercial version. But when I Google it, I got a lot of websites which asks money. So which we cannot afford it.
Sir, can I ask a question?
Yes, sir, please.
Sir, whatever now is a commentary list. So if we want to add a commentary, means we do conduct lectures nowadays on Google Meet.
Yes.
So if I show this on my screen, I can share the screen and meanwhile commentary.
Yeah.
So those things can be recorded, no? Because now.
Yes. Yes, that can be recorded.
Even if I want to prepare my own video with this, then also I can do.
Yes, yes, you can. Definitely,
Okay.
you can prepare, no problem. What I used to do when I conduct my Google Classroom, I used to record the session and then I will post it in the Google Classroom. Those who have been part of the class or those who missed the class due to connectivity issue, they can later just play the video and they can repeat the calculation and they can submit. All my students used to have a login credentials for this particular website. And now that is over. The temperature is given here 33.6, and now we need to do the calculation. Already the calculation and everything is given here. What we need to do, and the same way we need to, everything is given here, and we can go ahead. NaOH plus this. Procedure is given here. Time scale, HCl, NaOH, and a mixture, and how to do all these things. And we can say that heat of neutralization of HCl with NaOH is that much kilojoule. Everything can be recorded, and we can ask the student to do everything in their observation notebook and convert it into PDF, and then they can submit in the Google Classroom. Okay, this is one of the examples. There are many examples available, but I'm not going to show everything. But you can go and play with that. Click the options available and then play with that, and definitely you can do that. I'll just quickly show one more experiment, which is electrochemistry. The conductivity experiments which we used to have in our what to say in our PG practicals or some of the part of UG practicals, we used to have conductivity experiment. So we can have conductivity experiment also. I'll just share the link now. I'll show this. Is it visible to you? I'll just put it. Okay, I just shared it in the chat also. Now here, say this is a beautiful website. This is developed in 2003. Okay, but I just searched for my practical and I got this beautiful website. Here, conductivity experiments can be prepared here. For example, if you want to find out the conductance of a solution at infinite dilution. So what we need to do, we need to go for different concentration, and then the specific conductance should be measured, and then we'll plot it and we'll extrapolate to 0. Okay, so here various cations and anions are given. Hydrogen chloride, let us say HCl. When I click HCl, it says HCl. Temperature can be given 20, 25, 30, 35, 45. Let us take 25 degrees Celsius, and concentration 0.01. When I click OK, you look at that this particular system is a model of a conductivity cell, conductivity meter with this conductivity cell, and this conductivity cell is immersed into the solution taken in the burette, and we feel that this is 0.0010 is a concentration of the solution HCl. I'm clicking this. Now you see that this is dipped into the solution, and here you have a violet color knob. If you click that, this will indicate that the specific conductance measured for the 0.001 moles per liter HCl solution. Okay, we can ask the students to note down. So then what we need to do, we need to go for the next concentration, 0.002. Click here. This will again immerse. Click here. This will show the other specific conductance. Okay, so all these things are micro Siemens. Then again we can go ahead and keep on increasing the concentration. We can take 10 different concentration. Yes, ask the students to note down that I'm just giving here. Now you see this is out of range. So we need to change a knob from micro to milli. Click here. Again, click here. This will be giving value in millisiemens. So like that, microsiemens and millisiemens are given here, just as we see in the conductivity meter. Okay, so we can ask the students to note down the values, ask them to plot in the graph, and extrapolate to touch the the y-axis where it gives constant conductance at infinite dilution. This we can give, and every website or every practical will have the guidelines. So it is not a big deal for us to go and read the guidelines, and we can adjust the things there. And here, how to operate the simulation, suggested experiments, advanced experiments. And this is a very simple thing. We cannot do conductivity titration here, but definitely we can do this. But what other things we can do? We can go and verify the Kohlrausch law. Here they have suggested that what are the other things that you can do, and how conductance varying with univalent, unibivalent, all these things we can play with that. And solubility can be measured using conductance, and the conductivities of acetic acid solution, and at that calculate the ionization constant, and other things are suggested experiments are given here. And we can also go and verify the Kohlrausch law and other things here in the basic electrochemistry. So the options are given here, and we can develop some more experiments, keeping the facilities available here in this particular website. That is also possible here. Okay, this is a very simple but very elegant website. Okay, so I have some more websites. I'll just share this. I'll share. So if you look at that, I have collected around 70 to 80 websites. It is not possible for me to go into all the details, but chemistry curriculum based simulation, only simulation, no interactive things are there, which they are given here. You can type. I'll share this document with Dr. Londe, because he can share it with the participants. And just giving, I have collected the list of simulations for each and every activity. Conductivity, if you look at that, microwaves, or some game is there, radioactive, nuclear chemistry games, periodic table games, statistical simulator, spectroscopy, then interactive quiz. There are many small quizzes available which are very good. You can ask the students to play with that for the first 5 minutes before getting into the topic. For example, equilibrium, catalyst, acid base, Le Chatelier principle, and so on. All the websites are given here. How to prepare solutions. I think I can just quickly take this particular how to prepare solution, reaction rate, and measuring volume, heating curve of water, concentration, pH, molarity. All these things you can pH titration. The one that I'm showing here, every electroplating you can do, even gravimetric analysis, some spectroscopy, phase rule, all these things, chemical kinetics can be done here, and so on. Ross method, gravimetric estimation, and so on. I'll just quickly show a few more, and before winding up. Can I take 10 more minutes? Is it okay?
Yes, sir.
Yeah, thank you. So I'll just quickly go to some. Okay, I'll just stop share. I'll just go to the website, and I'll just show few things. Okay, I'll just start with the preparing solution, very basic thing. Already we learned that. So here you can ask the students to go and read that. This is a simple quiz. Okay, what size of volumetric flask you would like to use? 1.5 molar solution of 43.85 gram of NaCl. So click here, submit, continue. Then here you can find that 500 ml SMF is picked because next step. So here everything is measured, continue measure, click here, then we can see the step-by-step procedure here, add solute, add water, mix. That will do, only then just you click each step, it will be doing of its own. Then continue, add water so that it will reach the mark in the SMF. And we need to do invert flask, and then we need to ask the student to shake. And here you can find the score. The score is given here. And the next question. Everything is based on the preparation of some solutions. And each time when you click that, the different question will appear. So the same student will not, each student will get different questions, slightly in a different way, but the concept is very same, how to prepare a solution. This is a very nice, experiment. The other one that I would like to show here is, all these things I have taken from American Association of Chemistry Teachers. Here it's like a reaction rate. When we take the kinetics for undergraduate students, and this is a very simple reaction, how reaction affects with other controls. Let us say you can just run a reaction. We know that as time progresses, what about the amount of product is appeared? And then we have some control. Let us say concentration. Let us decrease the concentration. You see that left-hand side in the beaker, A plus B gives C. Decrease the concentration and run. And this will plot how the reaction will occur. And then you can see how slowly the products are formed. We can start over again, take concentration, increase the concentration, and what happens to the reaction. So small things, this is not a practical, but I would say these are the simple teaching techniques. Surface area. Let us say when we want to, talk about surface area, nanotechnology, nanochemistry, we can ask the students how catalysts play a role, how the surface area are important in the reactions, or especially rate of the reactions. All these things we can play with this particular website. And we can take this particular heating curve of water. I'll just share this website, but you can go back and you can look into the other practicals in this website. You look at that, you click on blue line here, temperature T1 and T2. Let's say I'm just clicking here. What happens? Solid, liquid. The two, it's liquid. Okay, the temperature 0 and then 24. And then let us calculate. Here, the energy required for the transformation is given by 21.7 kilojoule. Okay, like that reset, you can take any point here, but on the line, I would say that the temperature T1 and T2, what happens here? Here also, you can just like the amount of substance that you want to take. 5 gram, we can take. Okay, calculate what is the energy required. With this, you want to create a practical, and through that we can teach. Something like we need to, every teacher should look into that and do that. Okay, so other website is, okay, this is a website is like PHET interactive simulation given by University of Colorado. So here, what we need to do here, there are a lot of websites, practicals are available. Only you can download these practicals and use it offline, or we can simply click the interactive version and you can work. And PHET gives number of simulations, number of experiments, but we need to customize to our requirement. Just I click here, This is for the concentration. Okay. So here you have a knob here to give the dilution. Here you can just adjust the knob to reduce that. And here you have solid liquid. Let us take nickel chloride. You can look at that. I'm just adding the salt to the water given here. And then I want to check the concentration. What is the concentration? So when I dilute, what happened? You look at that, that concentration is keep on changing. All these interactive tools can be used to teach students the basic concepts of dilution, concentration, and so on. Sometimes what happens, they are actually giving some procedures, some calculations we can directly use. Otherwise, what we can do, we can customize small practicals based on that. Okay, there are many practicals are given here in this PHET Colorado website. Here you can take the simulations, physics, chemistry, maths, and so on, and teaching how to tips for using PHET, share your activities, and so on. And you can click here and click chemistry, biology, math, physics, and many things are there. I'm just clicking here, PHET interactive simulations. Let's take my solution. I'm clicking here. So here concentration is given, pH is given, and then we can add the OH and H3, H plus and OH concentration, and pH is changing. So with that, we can say what is the amount of pH. Acid-base solutions can be given here. Numbers are given here. Click here. You can see what is the pH 8.22, and then you have OH ratio is higher. And then 6.73, and you can have blue dots. Blue dot is H plus. You can give molecular count. What is a molecular count? All these things can be given so that the students can play with that, and the students can understand what is the theory behind each of the practicals. Okay, so I think I can stop at this level. I will share all those links to you. Around 600 practicals available in the ACS website that I have shown, and I have collected and listed on which are very essential for our teaching for undergraduation and post-graduation. Most of the experiments are designed for undergraduate students and of course high school students, in fact, but we can very well use those concepts and we can teach, especially when it comes to practicals. I find physical chemistry practicals we can manage to around 50%, and rest of the practicals we can develop. And one such practical I want to give it to you, which my student has developed. Can you see this website? I asked the students, okay, we want to do this practical in this pandemic, and we do not have all the practicals available. Then I gave values to him. For example, for the experiment called simple eutectic system. So we need to take the two weight of A and B. I said that, okay, you take 3 grams and you take 1 gram and then proceed. And you look at that melting point and freezing point are appeared here. And what we need for calculation is only melting point and freezing point. In the regular practical, what the student will do, the student will take the sample and then, you know, setting up a reaction like this here, in a beaker filled with water, a test tube filled with a cork and stirrer, thermometer, and then we need to heat the substances and to find out the melting point, and then slowly cooling down the system by using stirrer, and then we will find the freezing point. The same thing, and I asked the student to have, each student should get different value. So here he programmed in such a way that every time you change the situation, they will get different values. Like that, 46.17 plus or minus 5. In this way, we in MCC, we customized 3 practicals. Even though it is not a real virtual, or the student may not get the very hands-on experience, but still something is better than nothing. So in that way, we tried, and this is done by undergraduate student who is now in third BSc, and one MSc student is also doing. And one particular student came up with the app. He developed the app and he circulated through WhatsApp, and everyone can download the app, and using app we can do some practicals. So that also tested, and we are in the verge of doing it in a better way. But the process is still on. So what I suggest is, like, we can have a number of opportunities. Only thing is we need to go for the possibilities and try to capitalize the opportunity available. And the final word I would say that with a few of my thoughts, I'm just sharing here. Okay. Just going back to the practicals. Now, since everything I showed here, I don't want to go and show that everything in the PPT. Some other websites I'll just introduce and I'll finish. Okay. So here you can, this is a website, again, this is PHET. You can add proton and neutron, you can find what is a net charge, mass number, and so on. The same way we can play with the periodic table and elements, how atoms are arranged, how the electrons are placed. And this particular website will give an understanding about chemical kinetics and the gaseous states, solid states, crystal structure, and phase rule and everything. But the point here is this particular Java-based virtual chemistry experiment works only with very few browsers. It is not compatible with the Chrome. But you can have different phase diagram 1, 2, 3. And this is a very good virtual laboratory, which is given in a Chem Collective, stoichiometry, thermochemistry, acid-base solubility, and so on. Here it's a customized one. Slightly difficult to practice, but if you practice, you can definitely play with this particular website. Then I said this physical chemistry experiment, I showed this. And this is other website which are given by MHRD, Ministry of Human Resource Development, under the banner of National Mission on Education through ICT. Here in chemistry, we have a lot of other ultra laser spectroscopy virtual lab developed by IIT Kanpur, IIIT Hyderabad, Amrita Vishwa Vidyapeetham, quantum mechanics, organic lab, physical chemistry, inorganic chemistry, and so on. You can click and you can find. Even IIT Delhi has contributed a lot to this. So I said these are the experiments available in inorganic chemistry laboratory. And this is a critical micelle concentration, which we used to do in second MSc chemistry. In physical chemistry, this is a EMF measurement, which tried to show, but website was not working. You can choose here, you have a knob here. So we can choose the electrode and so on. We can find the EMF value. This is a downloadable version of the chemics. You can find, and small calculations can be given, which we cannot use it as a practical, but definitely the phase rule tertiary plot or binary plot, the phase diagram can be studied using this Chem Reacts virtual lab, again, which gives a better understanding about chemical kinetics, a robust version, chemical reaction simulator. We can take acid-base titration and so on here. A pH titration, how a pH with hydrolysis. This is again customized. We can download the molecular workbench. Everything is given in ACS website, which I showed in the very first. And some of the animated videos, but I'm not a big fan of animated videos because I want the students to have an interaction with the computers. At least to a certain extent, they should feel an experiment is going on. In conclusion, I would say that we cannot replace the regular laboratory practicals. Yes, it is needed. Faculty should spend in finding out some of the options available in the internet. Just Google it. Some of the websites are available. Just play with that and try to look at what are the options available. Faculty should devote considerable amount of time in customizing the experiment. The experiment may not be, may not be present there as it is. We can take and use, but we can customize. We can take a part of that and we can ask the students to do, change the values and ask them to do, plot it and coming up with the result. In the coming years, we need to develop a pre-laboratory course in these lines. Before entering to the lab, the students should work in the virtual laboratory for about half an hour to play with that, and then they can come into the real laboratory as we have a situation in abroad. So the days are not far away, and we need to keep our fingers crossed to look forward for that. And at the end, I would conclude with this: something is better than nothing. So we need to have something in this pandemic situation when we do not have any other option. Thank you very much for your patient listening. Thank you.
Thank you, Dr. Vijay. Very nice presentation from your side. I congratulate to you.
Yeah, thank you.
Okay. Dr. Kamble sir. Dr. Kamble sir. Hello.
Sir.
Yeah.
Okay, sir. Now, I would like to request the president of this webinar, principal of our college, Honorable Dr. K. Shinde Sahib. Please make your presidential speech. Honorable Dr. K. Shinde Sahib.
Good evening, everybody. Today, national webinar on introduction to virtual laboratory in chemistry, organized by Department of Chemistry, Reaction Samsthas, Karmair Bhaurav Patil Mahavidyalaya, Pandharpur. The resource persons of this webinar, Honorable Dr. Vijay from Chennai. The chief guest of this webinar, Professor R.B. Bhosle, Director, School of Chemical Science, Punyashlok Ahilya Devi Holkar, Solapur University, Solapur. As you know, all and participants from all sides. As we all know that entire world facing the problem due to COVID-19, it badly affected on different sectors of the economy, including the education. Colleges are still closed for the student. In such a condition, teachers in the college are delivering their lectures by using online modes. There are a number of video conferencing tools like Zoom, Google Meet, etc. But majority of the institutions are facing problem while delivering their practicals in science faculty on online mode. In chemistry, there is a preparation, analysis, instrumentation. It is feasible for the student to perform these practicals when colleges are open, but in such a condition, virtual laboratory is the prime need for the conduction of the experiment. The resource person, Dr. Vijay, explained so many things about the virtual laboratory with the help of number of websites, number of virtual laboratories, by giving number of experiments. Very nice presentation. Definitely it is useful for the participants, students. Our teachers will definitely incorporate your suggestion while delivering their virtual practicals. Professor Bhosle sir inaugurate the webinar. He is the representative of Punyashlok Ahilya Devi Holkar, Solapur University, Solapur. I request to Professor Dr. Bhosle sir, please incorporate some virtual practicals in the curriculum of Department of Chemistry. With best wishes to you all, I will stop here. Thank you. Once again, thank you.
Thank you, sir. Now we are coming.
I want to
yes.
sorry I want to have some actually query.
Yes.
First of all, I would like to myself Dipesh Ghosh from Vivekananda Mission Mahavidyalaya, West Bengal. Okay, and actually Dr. Londe, I did a course with him in 2016, and so he's actually known to me. He informed about this webinar, and I was wondering if any virtual practical at all exists. But I must thank Dr. Londe. If he didn't inform me about this webinar, I haven't any idea about this virtual platform of doing chemistry practicals. Okay. I must thank Dr. Vijay for his excellent talk, and also I request Dr. Londe to actually take the PDF. I also from Dr. Vijay and share it in the WhatsApp group form in this webinar actually. But I must congratulate Dr. Londe and Dr. Vijay for giving such an opportunity to us actually to learn about the about this type of webinar. Okay. Thank you very much. Thank you.
Thank you. Thank you.
Okay, thank you, sir. Now we are going to the last moment of this webinar. I would like to request Dr. S.S. Karale, sir, who is working in Assistant Professor in Department of Chemistry. Please propose the vote of thanks on behalf of Department of Chemistry and Karmavir Bhaurao Patil Mahavidyalaya, Pandharpur.
Hello. Thank you, sir. Hello. I am audible. Hello.
Yeah, yes, you are audible, sir.
रे शिक्षण संस्थास कर्मवीर भाऊराव पाटील महाविद्यालय पंढरपूर Department of Chemistry organizes a national webinar on the introduction to the virtual laboratory in the chemistry under the aegis of the RISA component A. The resource person of this webinar is Dr. R. Vijay Solomon, Assistant Professor from the Department of Chemistry, Madras Christian College, Chennai from Tamil Nadu. The talk given by him was very interesting, informative. He shared some useful website links, which is very important regarding the virtual practical conduction of the virtual practicals, and which is a truly benefited to all the faculties from the chemistry departments. So on the behalf of the Department of Chemistry, I thanks to the Solomon sir for accepting our invitation as well as delivering the lecture in our webinar. Further, I express my deep sense of gratitude to the chief guest of this today's function, Professor R.B. Bhosle sir, Director of the School of Chemical Sciences, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur, for sharing his valuable knowledge regarding the virtual laboratory. Then I am very much thankful to the president of our president of this function and the respected principal of our college, Dr. K. Sinde sir, for his constant encouragement and the moral support during the organization of this webinar. Now, as this webinar is organized under the RUSA components, then it's our duty to thank the RUSA coordinator. So many thanks to the RUSA coordinator of our college, Dr. B.B. Shitole sir. The special thanks to the IQC coordinator, Dr. Amar Kamble sir, and the Rajendra More sir for the providing technical assistance during the organization of this webinar. I am also very much thankful to the head of the department, Professor R.N. Zambre sir, and all the organizing committee for giving me opportunity to express the vote of thanks in this webinar. I also thankful to all the participants, those who are watching this webinar on the Zoom platform as well as on the YouTube live streaming. I also thanks to the all our PG students which are watching this webinar on the YouTube live streaming. And at last, I am also thanks to all those who support us directly or indirectly in organization of this seminar. So thanks all of you. Thank you. Thank you, sir. And with the permission of the president, I declare that this seminar is over. Thank you.
Thank you.
One more request is, will there be any link for certificate?
Yeah.
Okay. Thank you.
Dr. Kamble sir. Hello.
Sir, Chambre sir, thank you.
Thank you, sir. Bhosle sir.
Thank you. चांगले केले तुम्ही ऍक्टिव्हिटीज. कारण हे गरजेचं होते असली ऍक्टिव्हिटीज.
प्रॅक्टिकलच्या दृष्टिकोनातून
हा.
आपल्याला शिकत जाईल.
नाही नाही, खूप छान झालं. ओके सर,
Thank
थँक्यू.
डॉक्टर कांबळे सर.
हा साहेब.
हा, दीपेश घोष यांची काही शंका आहे, विचारा ना.
हा साहेब.
अबाउट सर्टिफिकेट.
हा, आपण I would like to request all the participant. We are giving a link of feedback to you. If you submit it, you will immediately get your certificate.
Right.
We already prepared certificate, and now we are giving a feedback link to the same WhatsApp group where you have registered.
Okay. Okay. Thank you.
Okay. Okay. So with the permission of our resource person, chief guest and president of this function, now I'm going to close this meeting.
Thank you.
Okay, sir. Thank you, sir.
Thank you very much.
Okay.
Thank you. Thank you, Dr. Balaji.
Thank you, sir. Thank you very much.
Thank you.